Hi guys, welcome to one more video. In this video, we'll take a look at max depth of the binary tree. So what we need to do in this video is we need to find the maximum depth from the root to the lowest child. So like the distance between root to the farthest child. So the difficulty level on this problem is easy, and the moment we hear like you want to do like depth first search, so obviously this is kind of like DFS. You want to like go to the depth of the tree. So the moment we hear DFS, the first thing that comes to our mind is stack or recursion. There's a very good probability that when you want to do DFS, you will have to use stack or some kind of recursion or some kind of that form. So let's see if we can apply this that in this problem and figure out the maximum depth. So in order to do this, what we'll do is we'll use recursive calls. So what we do is from root, we say that give me the maximum depth of left child or maximum depth of right child, and then I'll do +1 to it. Whichever is max in those, I'll do +1 to it. And likewise, we keep doing that for all the nodes. So let's look at the code and then we'll actually run the code on this tree. So what we do is we have our max depth method, and if our root is null, we just say return 0. If there's no child to this node, so this is a node, so it just root the variable name, so it's any node. So if left is null and if right is null, if there are no children, we just say you are at 1, like your height is 1, there's no more childs to it. Or else what we do is return max of this method again, max depth root dot left or max depth root dot right, either of two, whichever is max, do +1 to it. So we'll recursively call this method. So let's see how this will work. So what this will do is it'll call max depth on this child and do +1, right? Like whichever is maximum will do +1, right? So we'll just pick that one, and likewise it'll do on all of them. So let's just follow this path because we know this is the longest path. So it'll call left child +1, right child +1, and this one +1. Now when this goes here, there are no children here, left and right are null, so it'll return 1, right? So the depth of this node is 1. Now this function will return, so it'll become 1 + 1, right? Now this function, so the depth of 8 is 2, right? So this will go here, it'll become 2 + 1. So depth of this node is 3, so this will go here, it'll become 3 + 1. And now since on similarly like this will be 3, so whichever is maximum, this one is maximum, so this guy will become 5. So maximum depth of the tree is 5, 1 2 3 4 5, and that's the max depth of the tree. So really easy problem, simple DFS algorithm, and recursively call solves it. So as usual, as we do in all the videos, let's go to the VS Code, run the code, and make sure that we get the output.
Okay guys, this is our final code in the VS Code, Visual Studio Code. So this is our tree, exactly similar to what we had on the whiteboard. So I'm constructing the same tree, and then we are calling max depth and we are passing the root. And in max depth, we are doing the same thing that we discussed. So uh, if there are no child, return 1, otherwise recursively call max depth for left and right, and then do +1. I again screwed up left and right for you guys. So it's always reverse on the camera, so it's always confusing. So anyways, you guys got the idea, right? So let's run the code, make sure we get depth as 5. There you go. The depth is 5 for this tree. So that's correct. And that would be it. So short and simple. If you guys like the video, give me thumbs up, and then usual stuff, let me know in the feedback in comments, subscribe to the channel, everything, all the good stuff. Press the bell icon and keep coding, keep doing algorithm data structures, and see you in next one.